David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. I got one for you. What do you call an angle that's adorable? An acute angle. Haha. Okay, today's lesson is a review of coordinate geometry, and I believe there's an E there. Coordinate geometry. So this is the chapter we've been working through where we've been finding points and slopes and equations and things like that. So this is a quick review of all the key topics in there. Use this video as an indicator of where you might need to study this material. Okay, let's get started. So our first big formula was a distance formula, and we approached that gradually. What we did is we took a couple points on the coordinate plane and we used the Pythagorean theorem to find the distance between them. And the way we did that was we counted horizontal and vertical. We can make that line and that line. That's a 90-degree angle, so we know that this leg squared plus that leg squared is going to equal our distance, which is what we're after, is that distance there. So we can just count this off on the coordinate plane. 1, 2, 3. This is 3, and this goes from here 1, 2, 3, 4. So that's 4. So now we use the Pythagorean theorem to find our x here, or let's call that c. That's commonly what that's called. So this would be 3 squared plus 4 squared equals c squared. Okay, then we solve. This becomes 9 plus 16 equals c squared. 25 equals c squared. So now c is going to be the square root of 25, which is just 5. And in fact, this introduces you to a famous triangle. This is the 3, 4, 5 right triangle. So if you ever see two legs that are 3 and 4, you know the hypotenuse is 5. Also, occasionally I get questions where people will say, well, the square root of 25 is plus or minus 5. So shouldn't the answer be 5 and negative 5? Think about that for a minute. Okay, if you said distance is always positive, you were correct. There is no negative distance. This is 5 long. It can't be negative 5. So when we take the square root, we stay with a positive result. Okay, so then we moved on from this way of finding distance to using the formula, and that's the distance formula, and it's like this. x2 minus x1 squared plus y2 minus y1 squared, all under the square root. Okay? So this is more of a plug-in approach to finding the distance. You can always do it this way by making a graph, but sometimes we just need a formula to go nice and quick. So let's use these same 2 points and use the formula this time. So we have the points 2, 1, and the point 5, 5. I do my x1, y1, x2, y2, just so I don't get confused. My distance is going to be square root of x2, 5 minus 2 squared, plus y2, which is going to be also 5 minus 1 squared. Now we can finish this off. 5 minus 2 is 3, squared is 9. And 5 minus 1 is 4, squared is 16. And you can see where this is going. This is really similar to what we were doing here. So the distance is going to be square root of 25 or 5. But this way is using the distance formula, which is pretty much what you're going to do in this chapter. Okay, the next 2 topics we covered were first, midpoints, second, gradients or slopes. So let's do one of each of those. You might be asked, find the midpoint of AB, segment AB, and then they give you the coordinates of those 2 points. We have a midpoint formula, which is just x1 plus x2 over 2, y1 plus y2 over 2. Just like that. So now let's plug in some values. x1, y1, x2, y2. So the midpoint is going to be x1 plus x2, that's, well, let's just do the plug-in step. And then y1 plus y2, like that. Now simplify. 3 plus 5 is 8, over 2 is 4. 2 minus 7 is negative 5 over 2. Just like that. Okay, let's do a gradient calculation. So now we have finding the slope of segment PQ, and we're given the two endpoints of the segment. Minus 5, 1 is P, and 3, 5 is Q. Now your slope formula, or gradient formula, is like this. It's y2 minus y1 over x2 minus x1. And remember, this is the vertical change or the rise. This is the horizontal change or the run. So let's label our points again. x1, y1, x2, y2. And let's do that calculation. y2 minus y1. 5 minus 1. x2 is 3 minus negative 5 on the bottom. So we get 4. So this becomes 3 plus 5 over 8. And the slope of this segment is 1/2. Okay, let's talk about two special lines, horizontal lines and vertical lines. These equations are more simple than a line that has a gradient and isn't horizontal or vertical. You just have to remember how it works. So a horizontal line, that's a line that shoots along horizontally, has an equation that's y equals some value, some constant. So like y equals 3. That's a horizontal line. And the way to think about it is that no matter what x is on this line, because x could be 2 or negative 7 or 100, y is always going to be 3. So y is the up-down, 3 is right here, so this line looks like that. And this is y equals 3. So x can be negative 1, negative 2, so on, or positive, but y is always 3, horizontal line. Okay, let's take a look at the vertical line. Same idea, but now x equals some constant value, like negative 2. So that means that no matter what you're doing up and down, the back and forth is always negative 2. So this is a vertical line that passes right through here. That's negative 2. So this line is x equals negative 2. Okay? So no matter what y is, you can be way up high or way down negative, x is always 2 to the left of the origin. Okay, let's take a look at two other special cases where lines interact. So we have parallel and perpendicular lines. And this gets a little tricky. I commonly see people switching these two ideas on quiz or test questions. So make sure that this makes sense to you, and then maybe you jot down some notes to remind you. Okay, parallel lines have the same slope or gradient. Another thing we say about parallel lines is that they never meet. Okay? So here's a situation. I've got two lines. I've got PQ, this is this upper one, and this second one is RS. If PQ has gradient 1/3 and is parallel to RS, then the gradient of RS is 1/3. They have the same gradient. Okay? So they'll set you up in problems using this idea. So they might tell you that PQ is parallel to RS. They'll give you PQ's slope, and then they'll ask you some questions about RS. Maybe it's slope, but maybe they'll have you do a few more complicated things. So the main point here, parallel lines have the same slope. Okay, let's take a look at perpendicular lines. It's a little bit different. Perpendicular lines have slopes that are related by the negative reciprocal. So what I've written here is two lines are perpendicular if their gradients are the negative reciprocals of each other. And a negative reciprocal, for example, if you take the fraction 1/7, the negative reciprocal is negative 7 over 1. You flip the fraction and change the sign. And the way to test if you've done that right is if you multiply these two together, you should always get -1, which indeed, top gives me -7, bottom gives me 7, so that's -1. So that's your test to see if you've done your negative reciprocaling correctly. All right, let's take a look at this situation. I've drawn these two lines, M and N. I put the little box in there. That tells you that they're perpendicular. Then I'm also telling you here, this little bit of notation means M is perpendicular to N. Now it's telling you that M's gradient is -7/2. What is N's gradient? So think for a minute. Okay, if you came up with flip the fraction and change the sign, I think you probably got it right. So N's is M's is -7/2, so we flip it, 2/7, change the sign. It was negative, so now it's positive. That's our slope, our gradient. Now you can see if we multiply straight across, we're going to get -14/14, which gives us, again, -1. We also talked about two forms of equations for lines, gradient intercept and general form. So let's take a look at gradient intercept, by far the most useful of these two. Gradient intercept looks like this. Y equals mx plus b, where the x and y are what are usually, they're the numbers that are on that line, the coordinate points. And m is your gradient, or your slope, and b is your y-intercept. Okay, so this equation is really nice for graphing. We'll do that in a minute. Here's an example. Y equals 2/3 x minus 7. This is in slope-intercept or gradient-intercept form. Another way to think about that is it's the line equation solved for y. Y is alone on one side. So you might get some questions that ask you to convert an equation to a slope-intercept, the same thing as solving that equation for y. So in this equation, 2/3 is our gradient, and our intercept is the point 0, -7. Okay, let's take a look at general form. It's a little different. This is ax plus by equals c. So one thing to notice is that c, which is the constant, because it doesn't have an x or a y by that. So c might be 2 or -10 or something like that. And then a is in front of your x and b is in front of your y. Now there's some rules for a, b, and c. They have to be integers, no fractions. So if you wind up with one of these that has fractions, you have to multiply both sides of the equation by a big enough number to get rid of all the fractions. The other rule is that a must be positive. You can't have a be negative, okay? So here's an example of one that fits this rule. 6x plus 2y equals 7. That's a perfect general form equation for a line. Now here's one they might give you and ask you to convert it to general form. Pretty straightforward for this equation. What's wrong? Well, I have integers, I'm good there, but I have a -2x, and x must be positive. So let's do this. Let's add 2x to both sides, and I get 3 equals 2x plus 6y, and I can change that into the correct order to get 2x plus 6y equals 3. Another topic we talked about was points on lines. Now the key understanding here is to know that if a coordinate point, x and y coordinates, if that point is on a line, then the x and y values get plugged into that line equation and it works. It solves the equation correctly. So you get questions where it'll ask you, here's a point, here's an equation, is this point really on this line? Or does it satisfy the equation of the line? So check this out. Points on lines. Does the point 2 minus 3 lie on this line? Here's a general form equation for a line. So what do? We plug in. We plug in the x value, the 2 for x, and then we plug in the y value, -3 for y. We bring our 18 on down, and we work our math. And if this side ends up being 18, then we're good. If not, we're not good. So 6 times 2 is 12 minus -6, right? Because 2 times 3 is -6, but we're also subtracting, equals 18. I think you can see where this is going. 12 minus -6 is 12 plus 6, so that's 18 equals 18. And it is, yes, this point indeed lies on this line. Now, if you want to test yourself, you can try that one right now. Okay, let's see how you did. Same process, but you probably notice now I have a gradient intercept line rather than a general form equation for my line. Same process though. Plug in my y value. So what we're wondering is, does the point 10, 3 lie on this line represented by that equation? So I plug my y value in for y. 3 equals negative 4 over 5 times x, which is 10 plus 12. So there's my plug-in step. Now let's carry this on down. 3 equals, now what's 4/5 of 10? That would be 8. 4/5 of 10 is 8. I've got a minus, this is minus 8 plus 12. 3 equals, so minus 8 and plus 12, it happens to be 4. So this point is not on that line. Another topic we covered was graphing lines from equations. So I'm going to first do one from a gradient intercept, and then we'll also do one with a general form equation. So let's get started. This form is built for graphing. You can just do it nice and quick. This here is the y-intercept, or the point 0, minus 2. So let's throw that right on here. 0, no left, no right, minus 2. There's our intercept right there. So the line goes through that point. Now I have the slope. The slope here is rise over run, so that's 5 over 1. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. There's my second point. Now I can just connect them. Presto. Now, graphing from general form is a little bit more complicated. We have to remember a couple things about our intercepts. The x-intercept happens when y is 0. So we can find the x-intercept by setting y equal to 0. So I'm going to do that over here. X-intercept, set y equal to 0. So I get 2x plus 9 times 0 equals 18. Well, this goes away. 2x equals 18. So x equals 9, which is the point 9, 0. Okay, so that's the x-intercept. It crosses the x-axis at the point 9. 1, 2, 3, 4. That's right there. So that's where it crosses the x-intercept. Now let's do the same thing for the y. The y-intercept happens when x is 0. Okay, so it's neither left nor right. It's right on the y-axis. So x is 0. So we plug in 0 for x. You get 2 times 0 plus 9y. That should be a 9, David. Equals 18. This goes to 0. We get 9y equals 18, or y equals 2. So this is the point 0, 2. So 0, 2 is 0, 2. It's right there. And our line is going to go like that. Okay. Now if you want to be complete, you can put labels on the lines themselves. You can show the equation for that one. And then we could show our equation here. Not an absolute requirement, but if you'd like to be thorough, it's a good thing to do. Last topic, finding line equations. If this gives you trouble, you probably want to go back and watch the full lesson video from this topic, because there's a lot of moving parts. I'm just going to review 2 quick problems here. The first one, if you have slope and the y-intercept, this is your go-to for slope-intercept form, or gradient-intercept form, whichever word you prefer. So this is just a plug-in. There's not a lot of calculating. So for example, here I have a slope of minus 5 over 4, and the y-intercept is the point 0, negative 3. So all I do is I just start plugging it in. Y equals minus 5 over 4, there's my gradient, x minus 3. That's it. Pretty straightforward. This is just plug-in. Now this one's going to give us a little bit more work to do, but it's not too bad. Now we have a slope and one point. We don't have the intercept, but we do have a point, and we can use that. So what we're going to do is we're going to plug in everything we've got, and that will let us find the intercept, or the b term on the equation. So here's our form that we're going to use. Okay. Now we can plug in what we know. So this point is going to give us our y value. That's the y equals the slope, 1/3, times x, which is minus 3, plus b. So we don't know what our intercept is. If I get my intercept, then I've got my slope, and I can just go back to this method and write my line equation. So let's solve this. The only variable left is my b, so let's simplify on down. 1/3 times -3 is -1 plus b. Add 1 to both sides. Plus 1 there, so we get 5 equals b. So now I know what my b term is here. I have my slope from what was given to us. So now my line equation is going to be y equals 1/3 x plus 5. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.